You see that we are getting more options when we do that. Do you know why many students are not here today? Maybe there's trouble out there and we don't know. As he's doing, if you have questions, you begin to be thinking about your question. So what's missing?
Can you just multiply that, I think, by like the $5 that you could get by winning, so that if that equals out to
So you have two possibilities. Either you win or you lose, right? For the game to be fair, the expected profit should be 0. I told you that last time, maybe you forgot. For a game to be fair, the expected profit to be 0. So the expected price, the expected cost for a fair game is the expected revenue. So you just want to find the expected revenue. What do you win? What do you get? Did they say what you will win if you roll double? $5? Okay. So you will write that you win $5 or nothing. The probability 1/6, and then what is the probability of not winning? If the probability of winning is 1/6, what is the probability of not winning? 5/6, you have 0, 5, 1/6, 5/6, and then you compute your revenue and check if. Do we all understand what I'm saying? Please, if you don't understand, let me know. It's easier that way, right? You know, sometimes some people don't tell you their problem and they're expecting you to solve. So we don't want to do that in this class. Yeah. Pardon? It just happened that it's not helping you because it is 0. You're winning 0. If there was a number there, then you will need it. So that's why it looks like it is not useful. So we have two cases. Either you win $5 or nothing. This is your revenue. Probability of revenue is getting nothing is 5/6, and you compute that by understanding this probability. You get this one by understanding that probability. The expected revenue here is the fair price, because a game is fair if the expected gain is 0. I mean, nobody is thinking that I will win. Two teams are playing a fair game. Nobody should be before the game knowing that I will win. Otherwise, it's not fair. Think about it that way. So nobody is making profit. Nobody is losing. That is the meaning of fair, and it's about expectation. The expectation on a fair game is 0. Expected gain is 0. Another question? So we are doing 11, 13, 15. You see, sometimes in class you might not understand everything. That is why you have to do it. When you do homework, you now say, oh, I don't know this one. And when I will explain, you will understand better. Everything. So this is, it doesn't happen, I want to tell you, it doesn't happen all the time. The students are asking you questions. This is an opportunity in this class to learn. Because when students ask questions, you learn more. When there is no question, even though I will teach and finish fast, but I know you cannot learn very much. So can you read that number 15?
Tickets are sold at $3 each. Find the expectation if a person buys one ticket.
Did a person buy what?
One ticket.
One ticket. Can somebody do that?
I can show you what I did, but
Okay.
I don't think it's right.
It's already good if you know it's all right. You know, sometimes people don't know what they don't know. When you know what you don't know, is the beginning of knowledge. You should use one of those money. We have exam next week, right? What I have done this time is to give you an exam similar to what I will give, which is on Canvas. So in addition to your homework, you should do that one. If you don't want to do it, that's fine. But if you do it, it will count for 10 points. But when you don't do it, it doesn't penalize you. When you do it, it doesn't mean it adds 10 points to you. It's like an assignment of 10 points. You will add to the regular average. It can improve your score if you do it. Do we understand? So do it and submit it by Tuesday midnight if you want the if you want to be great for 10 points. Yet we are going to go over it on Tuesday. We'll submit it before class on Tuesday. I put it midnight because you have to submit it before class, otherwise I will do it and you will copy it and give it back to me. So I'm going to change that on Canvas.
I don't think that works out.
Why do you think it doesn't look good?
Like, I don't think it works out. Like, I don't know, like, how, like, I started the graph and then, like, getting down to, like, the actual calculation. Like, I don't think it works out correctly.
Let me borrow your book again. So it says that a lottery offers $1,000 prize, one $500 prize, and 5 $100 prize. 1,000 tickets are sold at $3 each. Find the expectation if the person buys one ticket. The person buys one ticket. Right? What are the possible winning? Let's put the winning on top. This one is for winning what? $1,000. This one is for winning, and this one. Did they tell how many tickets will win each of them? I think I had something like that.
They're selling 1,000 and we're buying
There is 5 price. There is 1 price for 1,000. And there is 1 price for 500. Then there is 5 price for 1,000. 100. Do you know where we should put that 5 price for 1,000?
Is that 5 of 1,000? Oh,
there is 5 possibilities for you to win. So we should put 5 here, right? Of those tickets, 1 has a $1,000 price. 1 has a $500 price. So this is 1,000. This is the revenue, 500 and 100. But this is way more because there are 5 tickets. So what are we getting here? We will change that, right? So there are 7 winning tickets. Can we say that? 7 winning tickets. So by doing the take-home problem, you will know how this exam will be structured.
yeah. Then you just add all these up on the bottom, and then that gives you 1. No, the 0.5 is not even right. That's just like what I got from my calculation. So when you add up the 1,000, yeah. Although I'm not sure if the answer you got for both is supposed to be negative 1.
So everybody should be working that.
So when you get like a 1, or whenever you do like that article, then you subtract 3, you get negative. Yeah, but that one could be 2, yeah. Or that one could be negative 1. If you did revenue minus.
Is it still not working?
The answer is supposed to be negative 1.
Mm-hmm.
And like with what we have on the board, if you add all of those up, it gives you positive 1. So that we didn't know if you had to do like the revenue minus
No.
what you would get the cost.
Oh. Anyway, you will come back. You are getting positive 1.
Yeah.
So it's easier to do this one, the revenue. To do the revenue, the expected revenue will be 1,000 times 1 over 1,000, which is 1, right? 500 times 1 over 1,000 is 1 over 2. Then 100 times 5 over 1,000 plus 1 over 2, which is equal to 2. Now you will do profit, expected profit is expected revenue. Oh, yeah. I see why you are getting the negative 1. Now minus costs, which is 2 minus 3. You are doing probably the reverse.
Yeah.
But this method to me is much easier, the revenue method.
So when you're getting like the 1/2 plus 1/2, like the 1 plus 1/2 plus 1/2, you're doing like just the revenue over the.
Yeah, I am ignoring this one.
Mhm.
This is the revenue. And with the probability.
Okay.
1,000 times 1 over 1,000. 500 times 1 over 1,000. Now 100 times 5 over 1,000. Because this number that is off, funny like that, it goes with 0. Yeah. So the fair price would have been $2. If somebody asks you, what is the fair price? How much should the ticket be sold to be fair? It will be $2. But if they do like that, are they going to make profit? No. Nobody will be selling lottery tickets. So, for example, in insurance company, you know, like they sell you maybe like car insurance. Anybody has a car insurance here? Your parents have it, right? So what they do when you want to get insurance, they begin to ask you questions. How old are you? Where do you reside? Any accidents have you had? And all of that helps them to determine the probability for you to get into an accident. And they will determine the probability to get into a very bad accident, just minor accidents, just regular accidents. And based on that, they calculate their expected profit by selling the insurance. So when they find the expected profit, which is generally this one, they now use it to determine how much they should charge you. They might now say, okay, the cost of maintaining this, giving you calls, sending you emails that you should come to us and all of advertisement, they put that into consideration. And then they now feel, actually, we want to have a profit of $5. So we say, okay, your insurance, the premium is $7. So that's how they use probability and statistics in business. Any other question? So what we are going to do now is okay. We are going to get into binomial distribution. So a binomial distribution results from a type of experience that will be called a binomial experience. I'm going to give you an example of binomial experience. I'm going to describe what a binomial experience is. A binomial experience is one in which you have a fixed number of trials. We start with a fixed number of independent trials. For example, tossing a coin 3 times, rolling a die 10 times. That is one step of identifying a binomial experience. In each trial, you will have exactly 2 outcomes. We will call one success and the other one failure. At each trial, the probability of success will be the same. You have 10 trials, and each trial, the probability of success remains the same. The number of success in a binomial distribution is called a binomial random variable. So we have a fixed number of trials. At each trial, there is exactly 2 outcomes. One is called success, the other one is called failure. So at the end, a binomial experiment is denoted NP XNP, where N is the number of trials. N is the number of trials. P is the probability of success. And we will say Q equals to 1 minus P is the probability of failure. X is the number of success. So example, suppose there is a 0.3 probability that a customer works in a store. Customer who works in a store and buy at least 1 product. All of this is about this. Most of this is about business. So we know that 30% of the time when a customer gets into a store, the customer will actually buy at least something. Find the probability that 2 out of 3 customers will buy at least 1 product. So to solve this problem, we will interpret it as a binomial distribution problem. What will be the number of trials? What do you think should be a number of trials here? 3. There are 3 people, and we want to know the probability that 2 of them is going to buy. So N equals to 3. And what is X? The number of success. Success will be the person will buy a product. So, and what is the probability of success? The probability that somebody that gets into a store will buy the product. Yes. We want to find the probability that 2 out of 3 will buy. So we are asking now, when an individual gets into this store, what is the probability that he or she will buy? Do we see that? Do you see that on the problem? We want all to know where to get each of those numbers. So probability of success is so we want to learn how to find the probability that X equals to 2. What will this be equal to? I could ask you this question without us actually doing all of this binomial distribution. Let's ask, what is the probability that nobody will buy? We have done this type of problem before. 30% of people who get into the store buy at least 1 product. If 3 people are selected at random, what is the probability that nobody will buy something? Do you remember how to do that one? Probability that none buys. We'll do 1 minus 0.3 times 1 minus 0.3. Do you remember it? Something like this? Yeah. So this is the probability. X equal to 0 means none, no success. So this will be 0.7 times 0.7 times 0.7. Actually, this outcome is failure, failure, failure. And the probability of failure, failure, failure is probability of failure and probability of failure and probability of failure. Because the trials were independent, if you remember. We said the trials were independent. And when they are independent, N is multiplication. So that is what we did before. Now, what do you think will be the probability that all three will buy? All three. Are you all following us? All three will buy. What should be right? This one is nobody will buy. This one is everybody will buy. What is the probability that the first person will buy? So, yes? It's just going to be 0.3 because those people are independent. And then 0.3, which is 0.3 Q. This is 0.7. We already have 0 and 3. So what is left is 1 and 2. Okay, now. Yes. So the probability that none of them buys, let S be buys. Let's just put it like that. You can buy 10 or whatever, but you bought something. That's success for the so failure, not buy. So we say probability of success is what? What is the probability of success? 0.3. Probability of failure? 0.7. So when we say probability of X equals to 0, we mean the probability that all fail. All three is fail. And that will mean probability of fail, 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 which is 0.7 raised to power 3. Right? For everybody now. Why is he doing this? So I give up for the screen and I work on the board. I write it here so that those who are on Zoom will see, because when it's on the board, it's difficult for them to see. So I will come back here whenever the screen comes. So now this is probability that X equals to 3. I want you to realize that I hope that you see the screen from here. So the probability that X equals to 3 will be probability of S, all 3, which is probability of S raised to power 3. Is probability of S times probability of S times probability of S. I want to save my space here, which will be 0.3 cubed. So look at what we are trying to achieve here. We are actually trying to build up a probability distribution. So we want X of X. We have for 0, 1, 2, and 3. For 0 here is, anybody has this number? 0.7 cubed raised to power 3. 0.343. And now 0.3 raised to power 3. So I'm going to erase this one so that we can continue to write. I'm going to do one probability for 1. E of x equals to P of x equals to 1. That means only exactly 1 will buy. Exactly 1 will buy. Then the outcome will be probability of, can we list all the possible outcomes here? So we will have S failure, maybe it's the first one that will buy, or is the second one that will buy, or is the third one that will buy. Do you think I've exhausted the possibilities? So in binomial distribution, we always have the question, how many outcomes are we going to get for that number of success? So, yes. No, the order does not matter. The order does not matter because when we say, okay, let me explain, the order does not matter here. So, when I say S, F, F, right, this is one outcome. I will say that this is one possible outcome, or this is another outcome, and this is another outcome. The probability of each of these outcomes is the same. Can you realize that? The probability is the same. So we are going to say that because saying that one success is first or second or third does not really matter. So out of these 3, we want to choose 1. It's only 1. So this will be 3 combination 1 to get this number. So I'm going to leave this one at 3 times, for success is 0.3 and failure 0.7 square. That is, I pick only one of them, and knowing that they are equally the same to do this. Now let's look at probability that x is equals to 2. I will see the same as probability of FSS, SFS, or SSF. And this will be 3.3 square times 0.7. So in general, you can compute, yes. No. It's because it's not because there are 3 people, it's because there are 3 possibilities of having 2 success out of 3. So I'm listing the possible outcome of 2 success out of 3, and it gives us 3. So it's because 3 and 2 are so close, that's why they are like that. So after this, I will change this to, just for an example, for visualization. I will make N5 and make X3 so that we see what we should do. Have you written this? Can I erase it? Okay. Can I erase everything on this board? Okay. Now what I'm saying is, I am going to we have finished this problem. We already have the answer for x equals to 2. That was what we wanted to do. Now, I want to explain the idea behind the number of ways to get that number of success. Suppose n is equal to 5, and x is equal to 3. That is, we have n trials with 3 outcomes. What are the number of success? I will give 2 or 3 of them. You could have failure, success, failure, success, failure. No, we already have 3. 5. This is one outcome, right? 5 trials, 3 success. This is another outcome. This is another outcome. This is another outcome. This is another outcome. So do you think we may be able to list all of them? We can get confused in doing this. So we may want to know how many outcomes are we going to get? I'm going to explain something a little challenging, but you might understand. Suppose I put this position as 1, 2, 3, 4, 5. Each of this position is labeled 1, 2, 3, 4, 5. This one is a 5. Yes. So we have 5. Can I say that an outcome here consists of choosing 3 positions and put S there? There are 5 positions, 1, 2, 3, 4, 5. Maybe let's say 5 boxes, 1, 2, 3, 4, 5. Getting an outcome of 3 success, meaning choose 3 balls randomly and assign success to it. Any outcome here will consist of 3 positions in which we have S. So if I choose the first case, which is this one, success is in 1, is 2, 4, and 5. Do we understand what I'm saying here? My success is in position 2, 4, and 5. Now, this is the answer to your question, which I could not explain with 3 and 1. If I say my success is 2, 4, 5, is it the same thing as saying that my success is 4, 5, 2 or 5, 4, 2? I'm getting the same outcome. Is that right? If I check the first case, I can say, okay, that is the selection 4, 5, 2. Somebody say, no, it's the selection 2, 4, 5. No, it's the selection 4. The order in saying that selection does not matter. Do we get this? Whether I say it is 4, 5, 2 or 2, 5, 4 is the same thing. Yes. No, that's not the way we are trying to say it. What I'm trying to say is that to find the probability of this outcome, I just need to know that actually this outcome is success is on the second, the fourth, and the fifth trial. And whether I say it that way or I say it is on the fourth, fifth, or second trial, I am saying the same thing. The idea behind it is that I'm telling you, you have 5 balls, number 1, 2, 3, 4, 5. Choose 3 out of it. In how many ways can we select 3 out of 5? And I want to say without order. Because order does not matter. If my selection was 2, 5, 6, it is the same as 5, 2, 6, and 5, 2, 5, 5, 2, 4, 4, 2, 5, and anyone. So meaning that if I get this one, it will be 1, 2, 3. I can say it is 2, 3, 1. It's 3, 1, 2. My aim here is for us to understand that the order in the selection of the position does not matter. We will have the same outcome. Then we want to know how many of such positions can we have. To determine the number of outcomes is to determine the number of ways to choose 3 numbers out of 5 without order. Does that make some sense? Then to determine the number of outcomes is to know in how many ways can you choose 3 numbers out of 5. So in how many ways can we choose 3 numbers out of 5? N of S will be 5 combination 3. So you don't really need to write this. So I want to say that you remember that. Now I will say that the probability that X equals to 3 will be 5 combination 3 times, if probability of success is P raised to power 3 times 1 minus P raised to power 2. Okay, so we are going to write it as 5 factorial over 3 factorial times 2 factorial P3 Q2. I try for you to know where that formula is coming from, but you don't really don't want to worry about it so much. Okay. Do you have your books here? How many of you have books here? Only 2 books? Okay. So now, binomial distribution. The distribution we have just referred to is called a binomial distribution. It is denoted by X, N, P, when X is the number of success, N the number of trials, P the probability of success. So the probability that X is equal to K is equal to N factorial over K factorial times N minus K factorial times P raised to power K and Q raised to power N minus K. So this portion of the formula is the number of ways to have K success. This portion of the formula is the probability of having an outcome with K success. P is the probability of success. So I know this formula is kind of hard, but we are not going to be using it. Only 2 books. How many are we? 3. We have a table in the book that I want us to use. So we are going to try to use it with that table. But let me see if I can get you know, you do your test here with your textbook, right? You do your text here with everything. It's open. So you can use Google. Look what I'm going to do on Google. I'm going to look for binomial distribution calculator. You see binomial distribution calculator? I'm going to use a binomial distribution calculator. Because in your textbook, you have a binomial distribution table. So towards the end of your book, here you have table. So we are going to learn more about it next week, But I want you to know that you have a binomial table. It is called table B. If you open here, you will have a binomial table. So on top here of the table, I know you might have your books at school. On top here of the table are the probability. Those probabilities that are in the book are the nice one, like 0.1, 0.15, 0.2, 0.3. You see, it's 0.05, 0.1, 0.2, 0.25, 0.3, 0.4. Those are some nice probability, like the one we had here with 0.3. So here you have the number of trials. And in the number of trials, you have the possible number of success for each number of trials. On top here, you have the probability. So if I ask you a question, for example, let's say I want you to find, let's do this one first. Let's do this. Suppose we want each of these numbers that we have here. You can use your textbook to get it. You can use this calculator. Or you can use that calculator. CIEC calculator. If you have it, you can use it. So let's start with this. What is the number of success here? So the first question is probability of success on a single trial. That is the probability of success. What is it? It is 2. Probability cannot be 2, right? It's probability. Look, probability of success on a single trial, right? 0.3. Unfortunately, I cannot type 3 here. If you have your laptop, you should try it with me because I'm not able to type my. For some reason, I cannot type here. I need to get the screen on-screen keyboard. Anybody knows how you get this on-screen keyboard from your laptop? You know what I call on-screen? Like when you turn it into tablet. You see me, it has turned to tablet. I've never used it like that. I think it is typing. What happened? Okay, let me see. Okay, now it is working. Okay. Oh, it's not. Yeah, it's there. It's there. Do we see what? Thank you. I'm sorry for this. I'm trying to use what I've not used before. So you can use it on your own laptop. It's because of all this zoom and projection. That's what is giving us so much trouble. So, and here is the number of trial. What's the number of trial? 3. And then the number of success now, 2. Yeah. Yeah, we can calculate. So how to read it? This first one is the probability that x equals to 2. What is the probability that x equals to 2? What is the probability that x equals to 2? Okay, everybody can do that. or you look into the table in the book, but having this one is much easier. TR 83 can also help you. Probability that X is less than 2, that is 0 or 1. Do you see less than? You see here, can I ask you probability that X is less than 2? Here is probability that X is less than or equals to 2. Please, everybody, can you see what I'm doing? Good. You go to Google binomial distribution, you will get one of these. I just want you to practice reading it. We can practice reading it and I give it this type of question to your exam. Instead of giving complicated questions, I will give some other questions. But when it's the binomial, I can ask you X is less than 2, X is greater than. You have it all here. Do I get that? Okay. So let's now complete with the mean, variance, and standard deviation of a binomial distribution. If X and P is a binomial distribution, then the mean X is E of X equal to NP. The variance of X is NP cube. Remember that this NP cube, remember that Q actually is 1 minus P. NP 1 minus P. And the standard deviation, square root of N. So if you have a binomial distribution, for example, N equals to 3, P equals to 0.3. If you are asked, if 3 people enter the store, what is the expected number of people that will buy a product? If 3 people enter the store, what is the expected number of people that can buy at least one product? We will say E of X is 3 times 0.3, which is 0.9. So about 1 will buy a product. If we are asked, what is the variance of this distribution? It's true, I know you know what we are talking about, but I will write it again here. If N equals to 3, P equals to 0.3, E of X is equals to NP, which is 3 times 0.3, equal to 0.9. The variance of X will be NP cube, which is 3 times 0.3 times 0.7, which is 0.9. Which is 0.9. Is it 0.63? Which is 0.63. And the standard deviation will be square root of 6. So if I give you a binomial distribution, I ask you to find the mean, variance, and standard deviation, is to do this. So after explaining this, I will just go over what is on the PowerPoint just to make sure that there is nothing we are missing. So we understood this formula. I explained it to you. I really don't ask you to use it, but if I ask you to find the probability, you can use either your calculator or you do this Google calculator or you use your textbook. Your calculator should be TI-83 to do the binomial distribution calculator. I will explain that next time if anybody wants. Then, so we did this for that example. We don't want to do it again. It's exactly the same thing, actually. Is what we just did. So if you have TI-83 calculator, you can find this on Canvas. It's the PowerPoint. I've recorded this. I will also put it on Canvas later in the evening. Okay, so we are done with chapter 5. Do your homework. On Tuesday, we are going to go over the homework, over the problem, the preview problem I have given to you. It is on Canvas already. Try to do it. We will go over it. Your exam will look like that. It seems as if my students that were on Zoom are all gone. I want to quickly check the attendance, so listen as I